Okay, today we are going to do problem 12. Oh, the glorious, legendary, hard problem of which I have done already. Okay. However, we are going to redo it. Oh, how do I reset? Reset. Okay. It says we need to find the median from a data stream. It says the median is the middle value in an ordered integer list. If the two sides of the list is even, there's no middle value. And the median is the mean of the two middle values. Okay. So, the way you do this is pretty tricky. But the goal of it is, let's just talk about what we need to do in this problem. Goal, find median of data stream, e.g. insert two numbers, find median, insert five numbers, and find median again. So basically, I'm inputting any number of numbers, any count of numbers, and at any time I should be able to find the median instantly. Okay, our inputs, let's just talk about parameters. One, number to be inserted as part of data stream. Param 2, we can say, well, we're gonna get, it's only one parameter. We're gonna insert one number at a time. Okay, output, as we mentioned before, the median at any given time. Okay. So since I've done this problem before, I kind of have some intuition behind this, but I can kind of describe the intuition before I even give out the answer. So first off, what is a median? Median is the 50th percentile number of a given, I'll say, collection of numbers. It's the 50th percentile from least to greatest. So that means 50% of the numbers are above it, and 50% of all the numbers are below it in value or in value. Okay, so the way we find the median is we take the top of the 50% below, or we take the bottom of the 50% above, right? That's the median. If the total total count of numbers is odd, we can take the middle. Assume odd one out is placed into the bottom 50%. If the total count of numbers is even, take the average of the top of the 50% below and the bottom of the 50% above. Remember? So for example, if we have 1, 2, 3, we split them off like so. Say we want the top of the bottom half and not the bottom of the top half. Now what happens if we have 1, 2, 3, 4? Well, we have the bottom half and the top half. So we take the top of the bottom half, which is a 2. We take the bottom of the top half, which is a 3. And then we take the average of them. And that'll give us 2.5, and here it gives us 2. So the question is how do we, it's not necessarily that we'll get them in sorted order. So how do we know which heap to put where? And that's a great question. So the way we do it is, suppose we're inserting these numbers, all right? We insert a 1. We always assume the bottom half first. Okay? And then we insert a 3. Well, do we insert into the bottom half or the top half? That's the question. Since 3 is greater than 1, we put it in the top half. Okay. Then we insert a 2. Do we put it in the bottom or the top half? Well, 2 is less than 3, so we agreed to put any odd ones out into the bottom half. And then we have a 4. 4 is greater than 2, then we put it here. Now there are some cases that I did not account for. For example, what happens if I have 1, 3, and then 4 here? We skip to this step here, and we say we've inserted the 1, we've inserted 3, and now we want to insert the 4. Well, we can't insert in the bottom half, even though it is the odd one out, because it's greater than 3. So what we do is we pop the 3 here, put a 4 in, put the 3 here. That's a special case. Now, of course, we also have the special case of 4, 2, 1, where we have 2 and a 4. Now we're inserting a 1. We put it in here. That's fine and dandy. Now, what happens if we have 4, 2, 1, 1, right? Now we have to insert a 1 into this specific scenario. We have to pop the 2 out, place it here. So there are a couple situations where we have to pop. Notice here the key defining factor. We need to know the minimum value of these values and the maximum value of these values. And we want to insert them rather quickly. Use a heap. So we have 2 heaps. 1 for the bottom half, 1 for the top half. Okay, so we're going to define 2 heaps. We have a bottom 50, top 50, bottom 50th, top 50th, right? Okay, so now we have those 2 heaps. We want to keep this as simple as possible. What I'm going to do is, just because the way heaps are defined in Python, you can only use min heaps, and the max heap you're going to have to multiply by -1. That's a bit, hard to read. So we are going to create a couple helper functions. Insert bottom 50th. Insert the bottom 50th, right? We have our num. So the way we do this is num is equal to minus num. Heap q dot heap push into our bottom 50th. Our num. And the same thing for our top 50th. Num heap q dot heap push top 50th. Or num. It's pretty clear. Suppose we want to get the let's call this push bottom. Insert bottom. It's fine if we want the maximum of the bottom 50th. We're gonna return num at 0. Num at 0 if length. No, we want the self dot bottom 50th at 0 if length of this 50th is greater than 0, else return. Here's the tricky part. We need some sort of code. well, let's think about it. It's either negative infinity or infinity, right? If I'm in this situation and I want to insert into the top here, I need to make sure that it's greater than this value. So if that's not, we're going to default this negative infinity so we can insert it into here if that's the case. Okay. Min top self turn self dot top 50th 0 length self dot top 50th is greater than 0 else float infinity. Now of course we have define pop bottom, return our result is going to be heap q dot heap pop self dot bottom 50th return result pop top 50th right. If I want the max, I'm going to take the negative of this. And the same here for the bottom. The max is going to be the negative of that. Okay. Now that I have my helper functions here, how am I doing on time? 12 minutes? Okay. Now I can say n is equal to the length of self dot bottom 50th. N is equal to the length of self dot top 50th. We're gonna have a couple cases here. If n equals m, they're the same. So that means we need to add to the bottom, but only if our number, if number is less than or equal to our max, our minimum top. Right, it's less than. That means we can add it to the bottom heap straightforwardly. So insert bottom none. Else, that means return. Else we will need to pop the top, right? That means that it's greater than that number, so we need to self dot insert to the bottom, self dot pop the top, right? And then we need a self dot insert to the top. Yeah, if it's greater than the minimum of the top, that means it belongs there. The minimum belongs in the bottom. So pop the top, insert that into the bottom, and what have you. Okay. Else, that must mean n is greater than m. So if n is greater than m, we need to say, okay, if num is greater than, if it's greater than or equal to self dot max bottom, right? That means it's this case. Where is it? here. If our 2 is greater, then we can simply, wait, it's this case, where is it? 1, 2, 4. If I insert a 3, that means I can simply insert it to the top, num, else it must be less than what's in the bottom. That means I need to insert into the top, self.pop bottom, and insert into the bottom our num. Okay. And then here, if n equals m, return self dot max spot, self dot min top, and divide this by 2. Now the question is, it wants me to return a float, so 2.0. Else we're just going to return self dot max. Makes sense. Okay, it does. Let me clean up this code to make it more Pythonic. Return and return. Actually, it's more readable like this, I'd say. It makes more sense. And okay, let's double check our code. If I insert into the bottom, I'm going to take the negative of it. Okay. If I insert the top, I don't do anything. If I take the bottom, I return the negative of it. Okay. If I take the bottom, I take the negative again. Top, I don't do anything, right? Because it's min. And let's check if 0 is equal to 0. Let's say they're both empty heaps. 0 is equal to 0. Min top will be float infinity, so yes, it will insert into the bottom. Now, what if I'm in the case of here, where I have a 1 here? If the number is greater than the max of the bot, so 5, insert the top, else. Okay, that makes sense. We'll run the code, check for errors. Okay. Let's run our test cases like we talked about here. What do I want? 1, 3, 2, 4. Right? So I have another add number here. Okay. What if I have not 1, 3, 2, 4, but what if I have 1, 3, 1, 4? Well, 4, 2, 1, 1, or alternatively 4, 1, 2, 1. Okay, and it works. Am I missing any case? So I have it when there's the test cases. Let me make sure I'm getting this right. So I have the simple 1, 2, 3. So ascending. You have an even number, and then you have one that's in the middle. Okay. You have an even number, and then you have one that's lower. Even number, one that's in the middle, lower, 1, 2 in the middle, and then you have one that needs to be higher, so 5 here. Okay. Okay, that should be all the test cases. middle, middle, high, middle, 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 low. Am I missing anything? No, I don't think so. It's a great problem. I really like it. And I think my solution here is understandable. So you have the bottom 50th, the top 50th, you have these helper functions, and you're checking, okay, is it the minimum of the top 50th? Then I take it as the bottom, and so on. So that's excellent, 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 excellent. All right, that's 20 minutes. Great warm-up. Hope to hear from you soon.